So in this video, our first one of Unit 8, we're going to talk about factoring polynomials. This is going to be kind of a long video with a lot of examples, but hopefully it helps. So with factoring polynomials, we're going to start off with reviewing factoring from last semester. So some basic factoring to start us off. The first step of factoring is to multiply a times c. So we have a, b, and c. So we're going to multiply our a, b, and c values. So a and c, a times c, makes 8. And I'm going to write my factors of 8. The reason we multiply a times c to find our factors of 8 is we need to choose from this factor tree two numbers that add to my middle term b. So the two numbers we're going to choose are 2 and 4, because I know that 2 plus 4 is 6. However, if you look at the first example, it's not positive 6, it's negative 6 for b. So if I need to combine 2 and 4 to get negative 6, I'm going to choose negative 2 and negative 4, because negative 2 and negative 4 together make negative 6. So after we choose the two terms for the middle that combine to negative 6, we're going to group the first two and group the second two terms. After we group, we're looking for what the first parentheses has in common. So if we look at 2x squared minus 2x, those both have a 2x in common. After we factor out the 2x, we are now going to divide what's inside the parentheses by what we factored out. So 2x squared divided by 2x is x. Negative 2x divided by 2x is negative 1. Then we go to our second parentheses, and we look at what does negative 4x and positive 4 have in common. They both have a 4. However, I don't like that negative that's in front of the x. So if we're working and there's a negative in front of the x, we want to get rid of that. So negative 4x plus 4, we're going to factor out a negative 4. So negative 4x divided by negative 4 is x. 4 divided by negative 4 is negative 1. And if you remember, what's inside parentheses here has to be the same, or we messed up. Luckily, I can keep my job because we didn't mess up. It's x minus 1 in both parentheses. And then we write our two factors. The first factor is what's inside parentheses. The second factor is what's outside. No, it does not matter if you wrote the other one first. So we factor it. We have our two factors, x minus 1 and 2x minus 4. Yes, I'm fully aware that we could factor out a 2 there, but it doesn't really matter. That's not what we're shooting for here. So, x cubed plus 12x squared plus 20x is the second example. So last semester, we only talked about how to factor a quadratic function, which is a function with an x squared. So, we haven't talked about how to factor a cubic function, but if we look at example 2, it's x cubed as the first term, 12x squared as the second term, and 20x as the third term. All three of those terms have an x in common. So since all three of those terms have an x in common, I can factor out an x. And once we factor out that x, we have this random quadratic, and we're going to factor it the same way we just factored. So we're going to multiply a times c, and this x outside right here, we're just going to keep writing, but it doesn't mean anything in terms of the problem. So until our final answer. So a times c here is 20. So I'm going to write my factors of 20. And I need factors of 20 that get to 12, so I'm going to choose 2 and 10. And then I'm going to draw an arrow here just so you know what this x is. Oh, you're fine. So we have x squared plus 10x plus 2x plus 20. So a bunch of parentheses are about to happen, but that's just because I need the outside set of parentheses in order to take care of this x. So we group the first two and group the second two terms. I'm going to keep drawing arrows so you know why I keep writing that x. And we look at what does the first set have in common. So they both have an x. And the second set of parentheses both have a 2. And again, when we're factoring, these two should have the exact same thing in parentheses. And then we write our factors. So we have an x plus 10, and an x plus 2. So that's the end of our factoring review. So now we'll actually get to the new stuff. So here on the left side of the screen, we have two formulas over here. We have this one and this one. And I would probably pause the video right here and write them down because I'm just going to start the example. So example 1, we have x cubed plus 8. And since there's a plus sign in the middle right there, we're going to want to choose our top formula that I highlighted because there's a plus sign in the middle. So we need to find two things for this formula. We need to identify A and we need to identify B. So A is the cubed root of the first term. So this is A cubed and this is B cubed. So the cubed root of x cubed cubed, sorry, I don't know why I say cubed twice. The cubed root of x cubed, the cubed root is the same thing as like a square root, but a square root is where like 2 times 2 is 4. So the square root of 4 is 2. A cube root is the same idea as a square root, except the numbers happens 3 times instead of 2 times. So the cubed root of x cubed is just x, because the cubed root cancels out the cubed. B is the cubed root of the second term, so you have the cubed root of 8, and the cubed root of 8, just like I said, is similar to the square root, but instead of the number happening twice, it happens 3 times. So to find the cube root, we'll try some numbers. So 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 again is 8. So the cubed root is the same number multiplied by itself 3 times. So 2 times 2 times 2 is 8. Therefore, the cubed root of 8 is 2. So we're going to go to my formula on the top, and everywhere I see an A, I'm going to put an X, and everywhere I see a B, I'm going to put a 2. So we have x plus 2, x squared minus 2x plus 2 squared, which we know is 4. And boom. So there's example 1. Example 2 is the exact same logic, just with different numbers. So we need to identify A, and we need to identify B. So A is the cubed root of the first term, so the cubed root of 27x cubed. And this we need to do two things. We need to find the cube root of 27, and we need to find the cube root of x cubed. The cube root of 27 is similar to 8. We're looking for a number that I multiply 3 times and get 27. So 3 times 3 is 9, times 3 again is 27. Therefore, the cube root of 27 is 3. The cube root of x, we just did. The cube root of x cubed is just x, because the cubed root cancels out the cubed exponent. B is the cubed root of the second term. And again, we're looking for a number that you multiply by itself 3 times and get 64. I'll just tell you it's 4. Then the second formula is what I'm going to use because there is a minus sign in between the 27 and 64, so I'm going to use the formula that has a minus sign in it. So we have a minus b, so 3x minus 4. And then we have a squared. But a squared we need to talk about for a second. So we have 3x squared. 3x squared means 3x times 3x, which is 9x squared. So make sure that we know that that is a 9 right there, not a 3. We have 9x squared minus 12x because 3x times 4 is 12x. And then plus b squared, which is 4 squared, which we know is 16. So that's my answer to example 2. Find the cube root of the first term, and that's your a. Find the cube root of the second term, that's your b. Alright, so the last thing we're going to talk about is something called factor by grouping. Before we get into this, I want to go back to how we factor something that looks like this. So how we factor this is we multiply a times c, then we find factors of a times c that add to b. So when we do that, on example 2, we did this. And we turn this into 4 different terms. And again, this is an example to relate back to what the question actually asks. So, when I have 4 terms like this, we say we group the first 2 and group the second 2 terms. And then we factor out what they have in common. So we'd factor out an x and a 2. And then we know that what's in parentheses right here has to be the same. So this is an example for reference that we're going to reference over here. So when we have 4 terms right here, we grouped the first 2 and grouped the second 2 last semester, which hopefully we can do by ourselves now. Here we're going to use the exact same thing. So this is technically new information, but it's an old technique that we talked about for a long time last semester. So we're going to take our first 2 and our second 2 terms, and we're going to group them. Then we're going to look, what do they have in common? So we have x cubed and 6x squared, so they both have an x squared. X cubed divided by x squared is x. 6x squared divided by x squared is 6. We look at the second set of parentheses and see what they have in common. They both have an 8. 8x divided by 8 is x. 48 divided by 8 is 6. And just like on the example that we referenced to the right, what's in parentheses has to be the same. So our first factor is what's inside parentheses. Our second factor is what's outside parentheses. And then the difference of what I have to the right and this example is we need to check to see does this factor. Does this factor right here. To do that, I'm going to switch colors. And we're going to go over here and try to factor x squared plus 8. So we multiply a times c, and we get 8. And then my b value here is 0. Because b should be right there, but it's missing. There is no b. So can I combine 1 and 8 and get 0? No. 1 plus 8 is 9. 1 minus 8 is negative 7, so that's not going to get me 0. I also cannot combine 2 and 4 and get 0. So, this x squared plus 8 is not factorable. which is an option now. If we try factoring something and we can't figure out how to factor it, we call it not factorable. Sometimes you'll see me write irreducible. I don't really care which one you use. Most of the time I'm going to write non-factorable, but if it's an old key or you're looking online or something, you may see the word irreducible. They mean the same thing. So since we can't factor any further, that is just my answer. Sometimes we will be able to factor the quadratic part and we'd have to go one more step. But since we can't factor or simplify x squared plus 8 any further, we're done.